So today we will see something about parsers. So we are aware of this part that there is a lexical analyzer, and parser is something which is in contact with this lexical analyzer regularly. How? It asks for token. Suppose it says get next token, and what it does, lexical analyzer returns the token, next token. In between, it may also store these information in symbol table. Okay, this may store and get, and this may also store or get, no problem. So the source program was here. Now what is happening? We have to understand what more things that this parser does. Definitely it asks for a token, gets a token, and now we are trying to understand what it does with the token. So basically it will generate a parse tree. Okay, so output of a parser will be parse tree. So with the help of these tokens, it will try to generate a parse tree, and then this parse tree will be given to your semantic analyzer. And further processing will start. So basically parser is something which is responsible for your syntax analysis. These tokens, when they are kept together, I should say, when you have a string of token, whether they follow rules or grammars or not. So parser will use a grammar, okay, to check these strings of token, a stream of token I should say. Together it can be called as a string. So these tokens which are coming from the lexical analyzer, whether these two tokens are acceptable in this pattern or not. This pattern means one token after another token. The grammar specifies a rule that what token can be where. So parser sees or checks whether these tokens, a string of tokens, satisfy the particular grammar or not. If it satisfies, okay, it is the string of token is acceptable, otherwise it is not acceptable. Okay. So I was telling you parser maybe of different types. So a parser can be either top down or bottom up. So when we call a parser top down, it means it tries to build the parse tree from the top, starting from the root towards the bottom or leaves. And these bottom up parsers are those which will start from the leaves and work together, work uh, towards the root. So in both the cases, whatever it is, top down or bottom up, so the input to the parser will come from left to right only, one symbol at a time. Now suppose this is top down parser, what I told, it will start from parse tree will grow actually from root to children. Let me write it.
Are you in class?
Yes.
You in class now?
That parsers. So top down parser and bottom up parsers. So in top down parser, actually parse tree will grow from root to leaves. Bottom up parser, here the parse tree grows from leaves to roots. Okay. Now so we generate a parse tree. You will try to understand later how parse tree is generated. You can understand that tree for a given string, one symbol at a time. What we do, we take at root and then replace this symbol with the possible symbols or terminals, whatever they are, and then later on these symbols can be further replaced. So when we every time replace the left one first, it is called leftmost derivation. Okay. So here for top down parser, it is leftmost derivation. Okay. However, in case of this bottom up, it is reverse of rightmost derivation. Okay. In rightmost derivation, what happens? We try to replace the right variable first. So why it is reversed? Reverse because we are trying to build the tree from in reverse order, getting a terminal first. From the terminal we will try to have from leaf towards the root we are making. So we are calling it reverse of rightmost derivation. Here in this case, in the leftmost derivation, what is happening? For one thing, for one symbol, suppose there are multiple options, S gives A, S, B, or it gives something else also. So you have to choose one of the production. This is a production, this is another production. So you have to choose one of the production in case of top down derivation, top down parsers, leftmost derivation. So what is it? Here you have to choose production. So choosing a correct production is little difficult. So this is the difficulty related to top down parser, where choosing right production is difficult. Okay. In bottom up parser, where what you do, for a particular leaf you have to choose one of the production which would really lead to the root. So this production, actually we call it a handle. Okay. So here you can also write it as identifying the correct handle is also difficult. Okay. Because you have to identify such handle using which you can reach the root or the start symbol, right? In top down it is very easy. You will always start from the start symbol, and somehow you will try to map and get the leaves as you wanted. But in case of bottom up parser, you will start from the handle. So choosing a correct handle here, let me write it. Choosing correct handle is difficult. Okay. Now, few more things that I will tell you is suppose here in top down parsers, what we actually want, we want the grammars to be free from left recursion as well as left factoring. So it needs no left recursion and no left factoring. Okay. Okay. All the for others also we will remove this left recursion and left factoring kind of things. If I have to name some of the parsers of top down parsers as well as bottom up parsers, I will name them. So let me start with top down parsers. So these top down parsers can be backtracking or without backtracking. Okay, so let me write it. They can be with backtracking and they can be without backtracking. Okay, so with backtracking means you will search in all the direction. From you will start from your start symbol, you will go in this direction, means choose one of the production. It doesn't work, then you will choose the next production, go till last leaf, and then you recognize though this is not the correct one, then you go for the next one and so on. Okay, so this is actually, I should say, brute force. Okay. Okay, if the spelling is correct, brute force. So with backtracking is brute force, means you are trying all the possible combinations. So definitely you can understand it will take more time, right? However, this is without backtracking. There are certain options without backtracking. If at all it is without backtracking, means we will not search all the possible combinations. If we are not searching all the possible combinations, in that case what we are going to do, we are going to predict. Okay, so they can be also called as predictive parsers. Okay, they can be also called as predictive parsers. Such parsers, they will, from a start symbol, they will try to predict. Okay, their prediction may be wrong. Okay, let's talk about it, whether it can be, what are the possibilities. But the thing is, they will predict that suppose we choose this production, then what are the possibilities of getting such leaves. So accordingly it improves the performance. Okay, so such parsers can be of two types. One is a recursive descent parser, and non-recursive descent parser. non-recursive descent parser. Okay, so recursive descent parsers will be one where you will have recursive calls from S with a little prediction. Okay. In non-recursive descent parser, you will have some kind of tabular structure which will help you in predicting. Okay, you will store some of the information in the tables. We will see how from those tables you will apply some algorithm and then try to predict what will be the leaves in future. So accordingly, which production is best. So it makes it easy. You will see. Let me name it. It is LL parsers. Suppose if at all it is LL1 parser. It means the first L is for leftmost derivation. Okay, no. The second is for leftmost derivation. The first L is for reading. Okay, it says that we are reading from left. Read from left. Okay, how many symbols? One symbol. Okay, it is saying one symbol. So on place of 1 it can be 2 or 3 or R. So any number n it can be. So it is saying that we can read these many symbols at once and then we can process. So usually it is LL1, which means we read one symbol and accordingly we process here with a leftmost derivation. So it happens, it was the story of your non-recursive descent parser and top-down parsers basically. So in top-down parsers you were having either with backtracking or without backtracking. If at all you are using this backtracking, it is basically brute force kind of thing. You are not predicting anything, you are trying all the possible combination. So it will definitely take more time than predictive parsers. In case of predictive parser, it will try to predict one of the production as more important. Okay. So here you are predicting one one production. So there are two ways of doing this. One is recursive descent parser, another is non-recursive descent parser. In case of recursive, you will have recursive calls to the symbols which are further derived, and in case of non-recursive descent parser, you will have some tabular structure where you will store some information and you will use some algorithm on the basis of which you will decide which production is good. Okay, this was the story of your top-down parser. Let me also tell you something about bottom-up parsers. Bottom-up parsers. So, in case of bottom-up parsers, definitely they are LR parsers, where we are calling it, okay, let me name it LR. So it is for reading from left and this is for reverse of rightmost derivation, right? But also let me tell you about operator precedence grammar parsers. Okay, so these let me categorize as two. One is operator precedence parser, operator precedence parsers. Okay, so basically these are the parsers which work according to the operators. Whenever some operator come and then since the symbols are there, you will keep on keeping the symbols, and when the operator comes, then you will start processing. This kind of thing it does. It will also have a operator precedence grammar accordingly, which it will work. The thing is, good thing about operator precedence grammar is that it also works with ambiguous grammars. Okay, it can work with ambiguous grammars. Okay, and okay, it actually work with the operator grammar, no problem. I tell you, operator grammar. The other thing I can tell you is LR parsers. LR parsers. Okay, these LR, you can understand this L is for left, reading from left. Reading from left. This R is for reverse of rightmost derivation. Such parsers. Now here these parsers, LR parsers, we have to study this in detail, don't worry. This LR parser are of other few types. One is simple, okay, before simple I should say, just LR0 parsers, SLR parsers, LALR parser, or CLR parsers. LALR parsers or CLR parsers. Okay, so these are other kind of bottom-up parsers. Definitely in these cases also you will have to make certain tables. You will have to, in this case you will also have to make DFA, and accordingly you will have to decide which handle is the correct one. You have to choose to reach the top means the starting symbol, and somehow some of these you can categorize as more powerful, okay, and accordingly medium powerful, less powerful kind of thing. And so they use certain kind of items. You will get to know maybe in a few time or after some time. They use items. So these two LR0 and SLR, they use LR0 items. And these two uses LR1 items. There are certain difference in this item. Item is basically the production only, don't worry. Production along with certain more information. Okay, that is LR1 parser. In LR0 it is just the production only, don't worry. So this was the story of your parsers, whether it be top-down parser or bottom-up parser. Now tell me if you have any